Hi, everyone. My name is Rohrer, and this is another 3D printing news Unpeeled. And today we have a number of news items for you. And we are now looking at HP, who, together with a Spanish startup called Athos, probably named after a mountain in Greece, I'm guessing, is making a 3D printed climbing shoe. Um, so this is a custom shoe. So with climbing shoes, the fit is very, very important. They have to fit very, very snugly. And these are then, made to order based on a foot scan, which the technology that HP has internally as well, and then are built using multi-jet fusion, which, as we know, is quite good at making parts in TPU and polypropylene, like these really flexible technologies. And if you look at the shoe, like a great big part of it is 3D printed. So it's actually quite new. We're not looking at just the midsole anymore. We're looking at quite a considerable amount of the structure here. So what I love about this is that there's actually a business case here. So a lot of 3D printed shoes to me don't necessarily make sense. They don't necessarily make sense because the cost isn't there, and shoe companies are just not used to paying those kinds of amounts. Um, in this specific case, we're talking about something that's really high performance, where maybe people would be willing to pay more. At the same time, the cost of the shoe not being comfortable or not working properly is very high to the climber, because that's the day she's been looking out for that whole week. Or you've flown all the way to Switzerland to climb there, and you need these shoes to fit perfectly on the 2 fantastic weeks of climbing or whatever. So the cost that the person bears on this thing and the risk that they have on the climbing shoe is much higher than just one of the many shoes that you may have in your closet. So I love the case of the criticality of 3D printing here really coming to bear, and us being able to make a specific geometry, and maybe people being able to pay much more for this. The other thing I like about this news is that the company Athos did not have to go to buy an HP machine and learn how to deal with it, and learn how to install it, and learn how to run it well. But instead, they just work with Sculptea. And these 3D printing services are a real accelerator by making your first prototype possible, and then scaling up production to your thousandth shoe as well. So I think there's a great business case. I know people have already talked about it, but I think this is a wonderful really case for 3D printing. The next thing is from Rohrer. Rohrer is a German kind of finishing company. There's a lot of like shot peening, all sorts of finishing technologies, and they have an AM Solutions kind of soft sub brand that makes tooling that makes kind of post-processing solutions for 3D printing. They've just released a post-processing plastic component system specifically made for powder bed fusion, and it's a continuous feed shot blast system. So the idea of course, is this: why do you shot blast things? To remove excess material, to make the surface texture more homogeneous, to maybe make parts a bit softer, more less abrasive, to make them watertight, to reduce the uptake of moisture generally, or to make them just better looking, essentially. You also, by doing this in a machine, as opposed to somebody in a shot peening cabinet or somebody using several different solutions to do this, of course, you hope to increase your overall kind of reliability, repeatability of your workflow. So this is very exciting news, because also right now we have automation solutions for 3D printing, and typically these are not line-based solutions. These are batch-based solutions. So the parts all come out of the powder bed fusion system. They then get conveyed to like a powder removal system. Then they get dragged to like a shot peening system or something else until they're done. So this is like the idea of doing this in a line-based form and a more of a production line kind of thing could mean much higher productivity, and it could mean much higher. It could deal potentially with much larger volumes at lower labor cost. What I also really love about this is that apparently these things that are on the market privately, this S2, which is a continuous feed shot system, has been on the market with some beta testers since May already. And 5 of these have been running 3-shift operations, the company says, with these beta partners. And one of them is a service, the other one is an OEM, and the other one is a consumer goods company. So I like the fact that they got these kind of heavy hitters to do this. And what I love about this news is that they're doing 3-shift operations. So this is not something standing in somebody's innovation lab. This is something being used day in, day out for 3 shifts. And I love that. And that is where we need to be manufacturing. None of this like innovation corner kind of innovation lab, competence center stuff. No, we need to be on the factory floor making things day in, day out. And so I love this very much. And I think this is, to me, it's quite interesting to see, okay, are we going to get the whole solution from vibratory finishing to dyeing? Is that going to be a line-based system? Does that even make sense? Or is it better to have like a round robin system with robots and stuff like that? I'm always really interested in this because it really does take us a lot closer to manufacturing these kind of things. Another thing that takes us a bit closer to manufacturing is Fathom, that has been using Mantle's technology to make tooling. So Mantle is a kind of binder jet solution whereby you deposit the the materials, kind of like a paste that gets kind of ink jetted essentially with the binder material, and then it automatically the Mantle machine already finishes it to make it nice and smooth. This allows for printing of a tougher kind of green state type object that is like less likely to fall apart, and at the same time also allows for very smooth objects and allows for printing of kind of really tough materials. That's where really Mantle shines as a technology. So the company then turned to tooling as its application. And I've mentioned this before, but I really, really like Mantle because they focus on this tool application. They just call all the people making a lot of tooling. Right? Do you like a lot of tooling inserts? Mantle wants to talk to you. And they have the exact materials that you need and you use, and they're making your thing. They're not talking to 10 different companies or 10 different industries, right? They just want to talk tooling and they just know everything about tooling. So I love this as a go-to market. Now, Fathom is another customer of theirs, and they're a large service, a 3D printing service, and they're now getting this tooling gig. Now, what they disclosed, and kind of like a white paper kind of thing they did, is that for a medical device customer, they made a tool that normally would take them, using conventional means, 200 hours of effort across 4.5 weeks to make it, these tooling inserts. Now it is reduced using Mantle to 110 hours and produce it in 2 weeks. So imagine how great this is for Fathom to be able to take on customers on reduced deadlines, to be able to say yes to more customers, and how great that is to save like literally like 90 hours of man hours on this one tool. That is just a lot of money. And imagine them doing this throughout the year. This Mantle machine is really kind of like the ROI on this is going to be huge for them. What they said is that they had a lot of milling, a lot of CNC milling was reduced, which also requires operators and stuff, and a lot of EDM was reduced as well. Now, it went from 100 hours of EDM, it's insane, to 27 hours. So it's a considerable thing. The object was made in H3 tool steel, and I love this as an example. I love this as a business for Fathom to get into this kind of very critical business to make like these medical device molds and tooling, and I love this as well for Mantle, and I think it's a fantastic company, fantastic startup. Azure Printed Homes, the California startup, is announced that it already has an order book of $16 million US, and it hopes to start delivering its first customers at the end of this year and the rest in 2023. It is also announced that it's going to order from Re-Inhabit, which is a home builder based in Southern California, for 10 3D printed homes. Re-Inhabit focuses on LA and Orange County, which is I think already Orange County is one of the largest economies in the world, so that's quite a large focus area. But what I love about this application is that it's essentially in California, they now have in certain counties, they have an accessory dwelling unit law, which allows you for the first time to, in a kind of suburban neighborhood, put a separate kind of house thing, a pod thing in your yard. Right, which could mean that, for example, you could make literally a mother-in-law's apartment for an elderly relative you want to take care of, or you could make a spare bedroom, put it in the yard, or you could make a studio, or you could make something that you could rent out, monetize your house. So this is a huge market in and of itself. And what I like about this is that this company is allowed to just kind of specialize in this, and that could be a gigantic market for them to. They don't need to conquer the world. They don't need to have a European subsidiary. They can just, in the Orange County area, print a whole bunch of homes. Now, what I also like is that the home builder says this is cheaper and it has a faster turnaround. Now, people have so far been focusing on solving the housing crisis with 3D printing. At 3dprint.com, we're intensely skeptical about that and put out a bunch of articles. Michael, our editor-in-chief, has done this as well, where we're really kind of saying, hey, guys, we don't know if that's actually going to happen. But what is something that people have not yet considered is, imagine you're a traditional home builder. You have to do a lot of planning. You have to put up your capital. You have to buy materials. Maybe you get paid half up front, half after the fact. And there's a lag of several weeks between, you getting paid the first time and you getting paid the full amount. So you often have to finance this kind of business, or you have to use a lot of your capital, right? Or you have to kind of skimp on stuff. That also works. But just generally, the time for when your money is returned to you is very important to you in these kinds of businesses, which is why a lot of these guys turn to gearing and other like lending and stuff like that to really turbocharge such a business. Um, but this kind of decelerates, or it takes a while for you to get your money. Now, imagine now you're a home builder and you just say to people, "Hey, would you like to buy a 3D printed home?" "Yes, I would like to buy a 3D printed home." Then you go to these Azure, you buy it from them, and you put it, and then in a couple of days you get your capital. And you may have been able to get the person's the homeowner's prepayment, right? Before, right? You pay Azure with that money. You install it, you do the foundation, and you install it in, let's say, 2 weeks instead of 6, and all of a sudden you get your money much quicker. So you have to deploy less capital, and you get your full payment much faster. So we need to really consider this is a really big opportunity, right? We need to really see that, okay, lower costs could make sense in some cases, especially with higher labor costs, but getting your money back faster and getting it without having to deploy so much capital could be really huge for a lot of home builders. So, and it could also be really interesting for a lot of financing partners to consider that these loans will be for much shorter periods. You could look at like factoring or something really different than just traditional loan structures for these companies. The next thing is also a 3D printed construction item. It's actually a demo thing. It was a pedestrian smart bridge, 5 meters long. And it's the Autodesk University conference was the scene of its unveiling. It was made in the UAE and by Autodesk itself and Lebanese company Dar Al Hansada. Handasa. It uses AI, robotics, digital twin technology, and also lots of sensors, making it a true smart bridge. Now, on the face of it, this is just a really fun one of these CAD company kind of fun things that they do every once in a time. They want to make everything smart, everything's IoT, Industry 4.0. Companies like Autodesk and Siemens are all about these kind of concepts. Now, the reason why I really do think there's something here is because we have to replace an awful lot of infrastructure that was built post Second World War across Europe and the United States of America out of concrete that's crumbling. There was also an awful lot of homes, bridges, and other kind of train, rail, and car infrastructure that was built in booms in these kinds of buildings in the 60s and 70s and 80s. This kind of stuff has an accelerated pace, has to be replaced, and it now has to be replaced in an environment where people are, well, much more expensive, and we're much more conscious of the environmental costs, right? So the smart bridge is a concept. Could be cool, predictive maintenance. We could, we could tell how many loads it's under. We could use this data to design better bridges of the future. Love it, right? But it also is kind of a safety blanket for regulators and for local county councils and builders to kind of allow them to adopt this complete new technology. Because we could print all of this infrastructure, or not all of it, but certain points of it, like, for example, small footbridges, small bike bridges, and stairs and other kind of infrastructure things like that. We could 3D print that out of composite materials that could then is much lighter, use less material, less emissions as well, and potentially you could then recycle most or much of that bridge at the end of life for a new bridge. So that in a more environmentally conscious, carbon conscious world is a real advantage. Also, the automated production reduces your labor costs on site and installing the thing and reduces the overall cost overall. Now, you can also 3D print out the concrete, of course, but both these things are really viable. So I'm usually very, very skeptical of kind of these, these claims and these things that the construction, that the CAD companies are all about all the time, kind of making these demo things. But this is one thing where I think that this could be a huge market. This could be a huge, growing, demonstrably profitable market where we have an advantage because we can make these things cheaper than traditional means. Anyway, so my name is Joris Peels. This is 3dprint.com, 3D printing news Unpeeled. I hope you really like this roundup of the day's additive manufacturing and 3D printing news.